So hello dear students, today's topic is elastic collision in center of mass system. In the previous lecture we have studied the elastic collision in a lab system, and now today we will study about elastic collision in center of mass system. Center of mass system. So firstly the question arises, what is center of mass system? So center of mass system is that system in which coordinate system is fixed with respect to the center of mass of the colliding particles. So as center of mass system is nothing but our coordinate system, then the collision will be taking place in center of mass system. So now we consider a mass m1 moving with velocity u1 collides with another particle of mass m2 and m2 is at rest. In lab system, this is the system that we have dealt in our previous lecture. So now firstly we convert the same system to center of mass system and study the same collision in center of mass system. So the velocity of the center of mass is given by it will be its formula is m1 u1 m2 u2 upon m1 plus m2. So it is m1 u1 vector plus m2 because it is at rest. So we are with m1 u1 m1 plus m2 equation number 1. So let u1 dash and u2 dash are the velocities of the particles in center of mass frame of reference before collision. According to Galilean transformation equations, u1 dash it is equal to u1 minus v. So it is u1 minus value of v from equation number 1 is so if we solve this, u1 is common, m1 plus m2, So it is m1 plus m2 minus m1, this cancels, so u1 dash, it will be m2 u1 upon m1 plus m2, and u2 dash, it will be u2 minus v, so it is 0 minus m1 u1 upon m1 plus m2, so u2 dash, it will be minus m1 u1 upon m1 plus m2. So this situation in center of mass frame of reference can be diagrammatically represented as, if you look at both the particles, u1 dash is positive, u2 dash is negative, so both the particles in center of mass frame of reference will be moving in opposite directions. This is mass m1, this is mass m2, and they will be moving in opposite directions with velocities u1 dash and u2 dash, and the center of mass, it is moving with velocity v. This is center of mass, say m1 plus m2, this is center of mass. So from the three equations we can take the inference that both the particles before collision will be moving in opposite directions and center of mass will be moving with velocity v. So now we come to the situation after collision. So let v1 vector and v2 vector are the velocities of the particles after collision in lab system, and v1 dash and v2 dash are the velocities of the particles after collision in center of mass system. So now we are again having two systems in collision, elastic collision, after collision rather situation, lab system and center of mass system. In lab system velocities are without dash, and in center of mass system velocities are with dashes. And if we try to depict the diagram, then say this is the center of mass velocity v, and the particle 1 is moving with velocity v1 as we studied in the previous article, and v2 after collision. Then this will be the v1 dash, this will be the v2 dash. So yellow colored velocities are velocities after collision in center of mass frame of reference, red colored velocities are velocities in lab system after collision, and green color is velocity of the center of mass. So according to Galilean transformation equations, v1 dash, it is equal to v1 minus v, v2 dash, it is equal to v2 minus v. So we mark this as equation number 4, So according to law of conservation of linear momentum, in center of mass system, so initial momentum is m1 u1 dash, m2 u2 dash, m1 v1 dash, m2 v2 dash. So if we substitute the values, let this is equation number 5. So u1 dash is from equation number 2, m2 u1 divided by m1 plus m2 minus m1 u1 upon m1 plus m2. It is m1 v1 dash, m2 v2 dash. So these two terms they cancel out. So m1 v1 dash, m2 v2 dash, it is 0. So we mark this as equation number 6. So from here m2 v2 dash, it is equal to m1 v1 dash. So v2 dash, it is equal to minus m1 v1 dash divided by m2. So this is the equation number 7, and it gives a very important result that v2 and v1 they are in the opposite direction, as there is a negative sign in equation number 7, and it is clear from the diagram that both are in the opposite direction. So that is v2 dash and v1 dash are opposite to each other. So in magnitude, v2 dash, it will be m1 v1 dash divided by m2. So we mark this as equation number 8. So from 5 and 6, we get m1 u1 dash, m2 u2 dash, it is equal to 0. So m2 u2 dash, it is equal to minus m1 u1 dash. So u2 dash, it is equal to m1 u1 dash divided by m2. So we mark this as equation number 7. Again, u2 and u1 dash, they are in the opposite direction that we have already depicted in this diagram. So in magnitude, u2 dash, it will be m1 by m2 u1 dash. This is equation number 8. So now according to law of conservation of energy of kinetic energy in center of mass frame of reference. So initial energy, final energy, so if we substitute the various values, this we take common, 1 plus this cancels out, half cancels out, m1 cancels out, dashes are there because these are the velocities in center of mass frame of reference. So conclusion is in an elastic collision in center of mass system, if the elastic collision is there in center of mass system, the velocities of the particles remains the same before and after the collision. Because this is the initial velocity of the first particle, this is the final velocity of the first particle, both are equal. So velocities are not going to change, they remain the same. And if we try to represent the total collision in a single diagram, then it will be represented like this, that if we have two particles, say m1 and m2, and they are moving with velocities u1 dash and u2 dash, clearly we have studied they are moving in opposite direction and they collide at this point, and after the collision both the particles they move in this direction. Say this is m1, it is moving with velocity v1 dash, this is m2, it is moving with velocity v2 dash, and let this angle is theta. So this is the diagrammatic representation of elastic collision in center of mass frame of reference. So this is all for today. Keep in touch for next lectures. Thanks a lot.